about map matching. I want to welcome all attendees of today's webinar about the xMapmatchServer. First of all, I want to introduce the player of this webinar. My name is Lars Moritz. I am technical consultant for developer components and geo-management and joined PTV this year. I am key account consultant for ADAC, Click Software and Daimler. My major topics are applications in the field of transport logistics. Today we have a joint webinar together with my colleague Joost Klaassen from PTV Netherlands. He is Senior Technical Consultant, Developer Components and Route Planning and joined PTV in 2006. Joost is Key Account Consultant for Benelux and Scandinavia. The men in charge of the technical part in the chat today are Bernd Welter and Tobias Bachmoor. Bernd Welter is head of the professional service team in our headquarters in Germany and also senior technical consultant, developer components and geo-management. Bernd joined PTV in 2000. His major topics are transport logistics and strategic optimization. Tobias Bachmoor from our software development department is director logistics developer components. Both will answer your questions in the chat. Our agenda today is subdivided into 5 parts. First, I provide an overview about map matching. The relevant questions addressed in this chapter are: what is map matching, why it is important, and what are the challenges? Moreover, I provide an introduction to basic tracking and map matching. Then I proceed with the technical background regarding local versus global matching. After that, I hand over to Joost, who will explain how map matching is actually done and exploits further functions. Joost goes on by explaining major use cases of map matching. After that, he gives some advice about using the right profile. The webinar will be completed by a demonstration of an xMapmatch demo client. So, what is map matching? The scope of map matching is mapping recorded GPS position to a digital map. The objectives are the detection of the most probable driven route in dependency on the frequency and the accuracy of the GPS signal. The challenge hereby is that GPS signals are inaccurate by design and even worse in real life. The graphic demonstration demonstrates the issue. The red dots are the coordinates of the recorded GPS trace. The actual driven route is identified by the solid red line. As you can see, the recorded GPS positions have an offset to the actual driven route. In order to run an analysis concerning speeding or toll cost, it is important to have the right data. If you match the GPS coordinate to a side street instead of the main street, you get wrong speed limits or toll cost. What the map match does not consider is finding the best routing solution. For that use case, we have the xRoute server. Map matching comprises the following ingredients. Since the GPS signal is not accurate, proper map matching needs to do a correction. This is done by taking into account the driving direction so that a reliable matching of GPS tracks to street segments of a PTV map can be achieved. During the map matching process, the matched locations, respectively the segments of the route network, the overall time and the length of the routes are determined. Moreover, the driving behavior, including mileage, brakes and speeding, can be dissected. So far to my part, and now I hand over to Joost.
Hello everybody, my name is Joost Klaassen and I'll be going into the technical background of the map matching One of the first major topics that we're dealing with map matching is something we internally call local matching versus global matching. Local matching is just getting the data of a single GPS point with only looking at that single GPS point. So you're not considering where did I came from, you're not considering where am I going to, just that single point. When you look at global matching starts off with doing local matching for points, but instead of getting one single result internally, it comprises a list of possible candidates, and now it can start looking before and to the back on to select the best candidate. So you're taking more into account than just your point to get more accuracy. Later on we'll see, depending on how good your signal is, how dense your signal is, when you can use local and global matching. Often we try to go for global matching for getting more accuracy. So going further into the technical background on how it's done. So the first element is what we internally have named our crawler element. So the crawler element will take your input signals, it will go point by point and look into the map for candidates. And you can see that in the image below, that basically every big circle represents an input with small black dots, all possible candidates. It then proceeds to rate each candidate. How far is the candidate from the original point? Is the road that the candidate is on, is it orientated in the same direction as your vehicle is driving? So in this way we get a list of groups of candidates. Normally if you would run local matching, xMapmatch will then proceed just to look in each group and select the best candidate. But if you would run global matching, and we get to the next slide, the history. So when global matching is enabled, we're going to look at history. And what basically happens is that internally we make a big graph from all candidates to all candidates for each consecutive point. And this is something you can see in the image below. So we started off on the right side with a point which apparently took loads of candidates. Then the next point still had some candidates, and you can see there are many paths to get from one side to the other side. Not all points are connected, so when we're going from one candidate to the next, we do already take some measurements into account. And what the history will do, it will start evaluating all the paths and will look for the most probable path. In this image given by the green line. And later on we can have a little look during the demonstration where I can explain a little bit more with imagery how this actually works. So apart from just the basic mechanics of map matching, there are in the background always some intricate details we have to take into account to get proper results. Driving restrictions, especially if you're in an inner city area, one-way streets or pedestrian area where you're not allowed to come, can generate easily false candidates. So these kinds of restrictions we do take all into account. Is your vehicle allowed to drive on this specific road in this specific direction? We're also looking at junctions. So we do try to see when we're going from one position to the next position, how many junctions did you pass to prevent unwanted loops. We also keep in mind, can you actually make a turnoff on a junction? It could be that, for example, turning left is blocked on a junction. This will all be taken into account. We also have a standstill recognition. When the vehicle is not moving, you will see that the GPS quality becomes quite bad. The signal starts drifting a bit from left to right, and this is something we can later on, and this causes very bad data to try to recognize. So what we do is we detect, is your vehicle standing still? If so, we stop the matching until you start moving again to keep a high quality data. We can process different kinds of signals, and when we're talking about kinds of signals, usually it's about the density. On how long does it take between two GPS measurements? This can be very dense, so once every second, or it can be very sparse, like once every minute, or sometimes we see cases where it's only once every 10 minutes. Depending on the use case, we'll later see we got different profiles to set up the engine to handle different kinds of signals. When looking at the output, some of the major requested things are, what kind of road is someone driving on? What's the speed limit of the segments? So these are data we immediately look up within the xMapmatch and return it. We also have possibilities to later on link to other standardized data set from our provider. For example, in Australia, we now have a use case where the customer wants to know, is this road a paved road or an unpaved road? Because he's renting out cars, and the people who rent the cars are not allowed on unpaved road because too much body damage gets from all the loose stones. And so these are data sets which are available on request, but by default we always have the road category and the most common speed limit. xMapmatch will also give you back a summary of the route. We'll see later on that that summary is a little bit small, but you can always take an xMapmatch result, pass it along to xRoute to get all the rest of the details you want. For example, like something which is mentioned here in xMapmatch is toll costs. And the last one, the vendor ID, I already talked a little bit. Extra information which is not included by default. We do have a lot available. Not everything is suited to put into our binary information, but then we can always provide you with a site lookup table. So now let's have a look at a couple of use cases. And the first use case, it's actually the most common one, fleet management, where track and trace providers, they get all the data within and they want to rebuild the routes after the fact. This is often being done in combination with an xRoute server. So the xMapmatch corrects the data and then the xRoute calculates all the details. And especially when you're looking at toll costs or emissions, or maybe you want to look further than just a default speed limit, because it's more and more common that we get time-dependent speed limits or vehicle-dependent speed limits. So this data is available as a site lookup. So right now it's mostly transport companies or telematics providers for transport companies who are doing this. And we're also seeing a lot of insurance telematics coming on, where people basically get discounts if they do not speed. Next use case is a pay-as-you-drive use case. So a company who rents out cars but doesn't have a fixed depot where people need to go to, spread around all around the city. And if you need a car, you go look on the app, where's my nearest car? You go take the car, you drive wherever you want, and you only pay for that amount of time. And here the time driven and the length of the route becomes very important to make a detailed report so that you can invoice your customer correctly. You can also look at, again, speed limit comparisons that, for example, you automatically give someone a fine if they're over speeding. And this is something we see a lot in some bigger cities with basically car sharing concepts. Another use case is for the processing of floating car data. So up until now we've always been talking about a track of a single vehicle. However, it's also very interesting if you have a big data set of a lot of vehicles that you can process this for detailed information. One use case is what we do internally, for example, is to create traffic patterns, commonly known as historic traffic information. But it's also heavily being used for our traffic department, that they get an idea of how is the traffic flow on specific times, so they can use this in their modeling techniques. So now we've talked about the use cases. I would like to talk about the profiles. I've spoken before that depending on the type of signal you have, you need a different profile. So we've got 4 standard profiles which are out of the box with xMapmatch to use, but you can always edit them, create your own profile and really tune your profile to your specific devices. For this presentation, I'm just going to stick to the profiles and how they work. If you want to go more into the details, I recommend that you get in contact with your technical consultant to do some more in-depth discussion about this. So we've got 4 profiles. Our default profile, which is recommended for half to 1 minute interval. It also does work with faster profiles. We've got our sparse, so that's GPS far apart, 1 to 2 minutes. Dense for close together and really on the second interval. And last is the local matching if your coordinates are very far apart, like 5 to 10 minutes, or you have different use cases where you do not have complete tracks, just isolated points. The first 3 profiles all work in global matching mode to get the most data out of it. And playing a bit with profile, it is important, and when you're working with xMapmatch and later on you're going to production, if you start playing with the parameters, you will find out that having the right set for the best quality, that everything matches, is important, but also keeping the profile, keeping the engine within performance. So this is something you really need to play around with when you start dealing with xMapmatch, but for now this is not part of this presentation. So let's have a look at the xMapmatch in action with a little bit of a demonstration. I've written myself a test client in C# where I can load up some data, try to play around with a bit of profiles, and let's bring that to the front. So right now I've loaded up.
Just one question.
Joost,
Any questions from the audience so far? If you have questions, just chat, and then we will give you some answers. But that was just a little interruption. Just go on, Joost, with the presentation.
Yeah. So right now you're looking at my tool. I've loaded up a very short track, and this is a track with a 1 second interval. So each blue dot represents an input point of the GPS. We can data we have as input. We've got our coordinates, in this case latitude, longitude. We have our heading, a speed, and just for myself I also recalculated the speed to kilometers per hour, and of course a timestamp. And these parts make a single input point and all the input points together. So we had a 1 second interval, so we need our dense signal, and let's match the data. So now we see a result coming back from the xMapmatch, and we see the green dots. So these are the output points, and these can be green, yellow, red, or white. Depending on green, I'm obeying the speed limit. Orange or yellow, I'm just over slightly over the speed limit, but it could be a measurement error. Red, I'm not obeying the speed limit. Or white, mostly in the case of Germany, there is no speed limit. We can also see the thick blue line, and that's the path the xMapmatch decided that I have taken. So we can see right now we got a very good correction. You can also see in this picture really where the measurements different from the stored map. Sometimes it's simply because I'm on a parking area at the start and the road is just be farther. You can see an inside corner, and here you can also see where I took a little bit of more of a shortcut. So this is an example of a very dense signal. For the other demonstrations, they're a little bit bigger, so I'm just going to turn off some details. So let's take a bigger track, and let's do a 30-second interval for the default profile. So this is a trip from Utrecht to Cologne. And this trip, because it's a bigger track, it takes a little bit longer to calculate. Also, I haven't really fine-tuned my profiles to really match up of the GPS device I was using. So I'm basically now training a little bit of performance for ease of it. Of course, when you're going to production, this is something you will do. You will fine-tune your profile. And what we can see is indeed that I am indeed getting full matches again. I am getting the full path. And what is interesting to see that we have a tunnel over here where my GPS device didn't record anything, but still the xMapmatch was able to continue through. And this one track is also, we can actually see right here that I stopped at the gas station to grab a cup of coffee. And you can see here I did a little bit of overspeeding, and later on he actually. So this track is also a nice example of, I want to have more details. For example, let's say if I'm a transport company and I want to know the toll costs of my truck. And what we can do is we can enable xRoute. So xMapmatch will send its results to xRoute. And since we're looking at toll costs, let me put in a truck profile. And let's see how many toll I have driven, or should have driven if I was driving an actual truck. So let's first have a look at the output now. You can see that there's a dark violet line included, and this is what the xRoute gives back, as this is the driven route according to the data. And if I compare it to the path layer, we can see, for example, here there was a gap where the xMapmatch didn't find a proper result, and there were some road constructions going on, and that caused a big shift. And you can see that xRoute will give now a difference in kilometers towards xMapmatch, because xRoute is not just for the matching, it's for finding the optimal route and can go on with these kinds of gaps. If we now would look at the toll, of course for the Netherlands I don't have any toll, and for Germany I've now got 11 euros and 82 cents in toll. So let's also have a look at a sparse signal. So I'm using the same track, just filtering out the details to once every 90 seconds. And again, we can see the results. We can see a little bit of a difference in the toll. So I had, if I recall correct, 11 euros something, now I have 13 euros something. So somewhere it took a little bit of a different route. And I'm not sure exactly where this happened, because it does look over here. We can see now, if you look at the xRoute line, some of the points were matched incorrectly, which causes what I always call loops in your path and extra toll. And here we can immediately see the importance of one, good profiling, but also on having a not too big interval if you want to do very detailed calculations. And of course, the last profile I want to show off is our local matching profile. Again, using so right now I've got a measurement once every 5 minutes. We can see local matching is actually very fast because it doesn't have to, for each candidate, look to it, its previous candidate and just in the end. So in this case with local matching you can also see xMapmatch can no longer comprise a total path, just we'll have segments for the points meant. In this case we actually got lucky that the local matching perfectly correct. Most of the times, however, this will not be the case, especially if you have measurements near highway crossings like here. A small error can quickly introduce a deviation. So this is what I can show you about map matching and the different profiles. Are there any questions about these demonstrations or something people would like to know about the map matching?
So at the moment there are no questions in the chat on open questions. Joost, if a customer is interested in this test client, can he get it and where and how? Because it's quite sexy.
Yeah, so I've this test client is available via GitHub. I've created a GitHub for myself where I always share my clients. If you want to have details, you can always go to our xServer forum, xserver.ptvgroup.com/forum, and here you find the different forums for the different xservers. Reading is public. For posting and asking questions you need to register for an account which is available for our customers. And within the xMapmatch forum I've got made a topic for the test client, and you can actually see some of the iterations. And so I moved it over to GitHub where you can get the full client with the C# source code, and the compiled version is also available within this test client. One thing which is not available by default but is right now, I'm using here satellite imagery. That needs to be licensed separately. By default my client looks, do I have keys configured for the satellite images? If so, I will take this into account, else I'll just use only the map. So right now my client has blended in the map, made it transparent and put it over the satellite imagery.
Okay, great. That answers my first question. And the second one is not to you, Joost, but to the audience. I just want to know who of you already uses xMapmatch. Just give me a little feedback in the chat. That would be great. And that's it so far from my side.
Yeah. So from my side, if there are not any more questions, I think I'm done with the presentation. Bernd, I don't know if you have some more general comments, or Lars.
No comments from my side. Okay, if there are no further questions, I think we are done.
Yeah.
Okay, so
Lars,
thank you, Joost, and
Lars, just give us a few seconds because now the questions are coming.
okay.
So maybe Joost, you can fill the time on the visual experience while Tobias is answering the questions. Yeah.
What we can do is, for example, let's have a look what happens if we do some other experiments where we deliberately take the wrong profile. So I'm going to reduce the polling interval to 10 seconds. I'm going to keep it at local matching, and when it's loaded up and matched, we'll have it a look at how will the results look now. I'm actually hoping that first someone.
Okay, Joost, one more question about your test line. Can you connect the test line to the xServer internet as well?
Yes, that's possible. So let me double check the internal settings.
I believe you. So for me, it's okay.
Yeah, so within the settings you can provide your token and then fill in the test URLs. When the version is compiled, you will have a config file where you can set those settings in.
Great, that's important. And maybe a little feedback about what we already experienced in the past with users who have this kind of questions. Especially Lars and me, we had some customers in the recent months who wanted to perform the use case of map matching, but they tried to use our xRoute. So what they created, or what they did, was they created a waypoints list, for example 300 coordinates as a waypoints list, and sent this list to xRoute to perform standard routing. And just a little experience, this is not working. The response time is bad and the quality of the output is not really what you can get from a proper map matcher. So this is why we decided to offer the map matcher in a webinar, just for your information.
Yeah, and right now on the screen you can actually see an example what you would actually see if you provided just GPS coordinates to xRoute and leave it at that. That points will be connected to, for example, on the highway, a wrong driving direction, and you get all these kinds of loop results. And in this case, since I'm using local matching, there's still a little bit of an error rate. That's why they're coming in. What we saw previously with the global mode, the error rate drops down significantly. Yeah, so also to be sure about the speed limits which are coming back are the most common speed limit on that specific segment. It could be that there are multiple speed limits on that segment. If you're interested in using that, you can use the vendor ID later on, and we can supply you with a separate lookup table for total speed limits. For example, in Germany, it's not uncommon on highways to have a weather speed limit. So if there's bad weather, the speed limit drops down, for example, to 80 kilometers per hour. In the Netherlands, we're seeing actually a lot of time-dependent limits, that during the day it's, for example, 100 kilometers per hour, and in the evening it's 130 kilometers per hour. So those details there may be not available directly from the xMapmatch, but we do have them available as separate data sets.
Okay, thanks for that, Joost. This invitation for this webinar, I think we sent it on a rather short term, just a few weeks ago. What we are also interested is in what kind of topics are most interesting for the audience. So use this opportunity to tell us when you have generic topics like strategic area planning, or we would like to know more about how feature layer works, for example. Use this. Just give us feedback about what you are dealing with, what you have not found, let's say, in the documentation, and whether you need more technical information or more, well, let's say, improvement of documentation, or what kind of information you would like to get from PTV, from whether it's from the headquarter or from the subsidiaries. We are working together, as you see at the moment, with the Dutch colleagues, yeah, but also hand in hand with our Italian, French, and US colleagues. And then we will decide whether we can offer a German webinar or, once again, an international English webinar. So today's map matching webinar is available only in English, and but we will decide this topic by topic. One interesting question here in the chat is which control is used in the test client, and I can answer this. It's the xServer.net control. So this is a special, some kind of library that we also provide. It's available for download. Joost, can you go back to maybe you can just show the download area? So the xServer.net is available in our protected developer zone customer area. Once you're logged in, you can download, I think it's in the xServer.net. There you go, here it is. And then you can just use this kind of control in your Visual Studio. Maybe you can just show that kind of integration into Visual Studio, Joost. Just show that control, how easy it is to drag it from the side list, from the tools bar.
I quickly have to stop it from running.
That's, this question, by the way.
Well, I'm actually using a community edition of it is part of the control, but I'm using a community edition of Visual Studio. It's the free version, so I had to add this one manually, but basically you just have the forms map and you can drag it onto your designer view, and then you have the control.
Yeah, and the source, you just have to assign the service URL of the xMapmatch that is to be used, and that's it. If you want to use it in the cloud, then you have to provide your credentials, but the integration is quite sexy. It's quite cool. You can benefit from a lot of developments. And one more information about this tool, or this control, is part of our desktop software named SmartTour, for example. So this is not a little library created by Joost just for this test client. It's really a control that we use in a product suite from PTV. And it's a very mighty thing. So, and as I said, this question is not off topic. It's, well, use any kind of, just ask any kind of questions you have. It's your opportunity to get information from the experts in such a webinar, and whether you are asking about map matching today or something which is a little bit side topic, no problem. We will give you answers. But now looking into the chat, let's see. I think we're done with the questions so far. Thank you. Joost, Lars, how about a ramp up from your side?
I would say that was the webinar, and if there are no more questions. It doesn't seem so. So I wish everybody a nice afternoon.
Yeah, also for me, if there are some other questions later coming up, feel free to go to the forum and make a post. Or if you have questions which have more sensitive data attached to them, feel free to contact your technical consultant to have a look. Is xMapmatch maybe something for you? And with that being said, I also wish everybody a nice rest of the day.
Okay. Same from my side, and Tobias, thank you very much for joining, and we will keep you up to date with future events. Eingedost heißt? Okay, one final question is whether we provide a record of this webinar. Yes, we will do. I will stop the recording in a few seconds, and later on we will just put it on our webinar archive page. And let me look server, because I'll just show you what that means. So make me just for a second, make myself moderator.
If I may interject for one moment, I'm seeing a question. Temporary speed zones such as school zones. There are actually some temporary zones in the data. If you're talking about temporary in the sense like a school zone, however, the data isn't always fully complete. So we saw in Australia we do have some areas, but also the example I gave with temporary speed limits depending on the time of day, there is data available, but it's not 100% complete.
Okay, I'll hand over the display to Lars once again. And then you can show your final slides if there are any.
No, it's just the last slide. Hoppla. No last slide for me, but thank you very much for attending this webinar.
Okay, great. Thank you all, and bye-bye.
Goodbye.